Hello, this is a very special Weather Optics video discussion on Hurricane Irma, which is now a Category 5 hurricane. This is your meteorologist, Stephen DiMartino. We're going to start off with the water vapor satellite picture looking at North America because it gives us a full idea of what we're dealing with in the 500 millibar pattern and what is happening with Irma. I want to key on this right here. Why is this trough important? This trough to the south of the Aleutians is a huge calling card for us. What it tells us is that when a trough is to the south of the Aleutians, like what we're seeing here, it leads to a greater potential for a trough to the southeast and over the eastern United States in general. And that is going to be a very, very important factor. Now notice on the water vapor satellite picture, disturbance after disturbance, shortwave after shortwave, is diving through the Canadian plains and heading down towards the Mississippi River Valley, Tennessee River Valley, and Ohio River Valley. That, of course, is going to lead to short waves intensifying as they move into this region, just in time for Hurricane Irma to approach the East Coast. Now, right here is Hurricane Irma. Here right now is a cold front that is slowly moving through the eastern United States, that is expected to produce waves of showers and thunderstorms from the southern mid-Atlantic all the way up into New England over the next 48 hours. Meanwhile, notice this trough. It's kind of like a pendulum, right? Here's the base, and the trough axis is kind of tilting from positive to neutral to negative. That process is going to allow for little pieces of short waves, little pieces of energy to dive south and potentially cut off from the main polar jet stream. And that is going to be the key to the forecast as we move forward over the next 7 days. So let's dive into Hurricane Irma. This is it right now. As of 8 a.m., 175 mile per hour winds. That is a Category 5 hurricane. The pressure is down to 929 millibars, and it is intensifying. Currently, the hurricane is 270 miles to the east of Antigua and moving to the west at 14 miles per hour. This is a dangerous situation, ladies and gentlemen. This hurricane is one of the strongest we have seen in the Atlantic Basin, and it has the potential to get stronger, especially if it remains to the north of the Leeward Islands and to the north of Puerto Rico and also Hispaniola. So this is a major storm here that we're dealing with. And take a look. This is the textbook picture of a Category 5 hurricane on satellite picture. Notice a couple of factors here. You see how the cirrus is kind of fanning out here? This is an indication of a strong anticyclonic circulation. Warm core low pressure systems or tropical low pressure systems typically have or always have a high pressure on top of it. That way it ventilates all that moisture being lifted and then kicks it out away from the storm to allow more thunderstorms to grow. So you're seeing an indication of that process happening right now. Meanwhile, we have a very impressive central dense overcast with a very clear eye. So what you have here are all of the calling cards for an intense hurricane. You have sinking air at the center of the storm. You have rising motion around the center of the storm. That's called the eye wall. Now, this hurricane is going to fluctuate in strength, primarily because of what we call the eye wall replacement cycle. And what that basically means is that as the hurricane travels on through, it replaces the thunderstorms within the eye wall. And as a result, it sometimes weakens and then re-intensifies and pulses up and down. So that is pretty much the only factor that's going to be influencing this storm. Why is that the case? Well, let's take a look at the water vapor satellite picture again. You see how the atmosphere appears to kind of almost be getting shoved out of the way. You know, this hurricane is buzzing through like a buzzsaw, and all the atmospheric influences and environment around it appears to get shoved out of the way. Why is that the case? Well, let's take a look at the winds. Here we have the surface winds here, and you can see clearly all this air is rotating right into the center of the storm, getting sucked in almost like a black hole. But what's happening in the upper levels? This gets even more interesting. You see all that air getting sucked in, it has to rise someplace. And it's rising all right, and at 250 millibars, what's happening is that all that air is being evected out. That way that the circulation is completed and you have a complete warm core engine. Unfortunately, that also means it's creating its own environment. You see this little buffer zone here, this little buffer zone there. You see that the upper level winds can't seem to really influence it at all. So what's happening here? Well, what's happening is typically when you get these type of major hurricanes, you get what's called a situation where it develops its own environment, where it no longer is influenced by things like pesky dry air or some weak to moderate wind shear. It's going to need a major trough, a major synoptic or large-scale feature to really influence the direction or the strength of this hurricane. Outside of this hurricane making direct landfall on some of the greater Antilles where you have some mountain ranges and it can disrupt the low-level circulation, there really isn't much that's going to inhibit this storm from continuing to intensify or to maintain the strength it's currently at. This is a dangerous storm, and the thing that really kind of worries me is that as it's heading towards the Bahamas, it's moving towards some very warm waters and the entrance of the Gulf Stream here, and that basically means you're just going to add kerosene to this fire. Okay, so you have all of the ingredients in place for a very impressive Category 5 hurricane heading towards southern Florida. So what's going to cause this storm to make landfall and turn and not move directly into the Gulf of Mexico? Well, what we're watching here very, very carefully is the evolution of this storm in terms of influence from synoptic features. Now, on the surface, you can clearly see that the latest GFS guidance basically turns our hurricane northward and basically sends it right into the Florida coast and travels up the Florida peninsula. Now, the WeatherOptics forecast basically still ranges anywhere from South Carolina through the eastern coast of Florida and then possibly along the western coast of Florida towards the Florida peninsula, or should I say Florida panhandle. Why do we have this forecast set up here? Okay, what's the factor here? And by the way, this is Jose, but don't worry about this right now. We have more than enough on our hands. Here is the factor here that we're watching. Keep an eye on the southeast. Now, you see this little disturbance right here? Watch how it evolves. You see that? That's a piece of energy that has been diving out of Canada and heading towards this trough, this weakness over the eastern United States. The development of this feature here is going to determine when our hurricane turns north, okay? Because it just becomes strong enough and produces just strong enough of a jet streak here to draw this storm north. Now, if this develops a little bit faster than what we currently have modeled, again, this is 5 days out, certainly can develop a little bit faster or a little bit slower, that will determine when our hurricane starts to turn northward and head into that what we call area of weakness. So that's essentially what we have here, is that we have carved out in the atmosphere an area of weakness, a path for this hurricane to go towards. Right now, it's basically directing it right towards the Bahamas. The question is whether that area of weakness allows the hurricane to turn north while it's passing the Florida Keys and then up towards the Florida Panhandle, or whether it does so sooner, cutting through the Bahamas towards the east coast of Florida and then towards the coastal waters of Georgia and South Carolina. That is the primary question that we're going to have to work on and answer over the next several days as we move forward. So that's the primary question. And to be honest, we're not really going to know until we get a couple more days and more data. The good news is that the National Hurricane Center and NOAA is using all of its resources to get the most data possible on this dangerous hurricane. So you can be sure to stay with WeatherOptics. We'll have the latest information on this storm and the best forecast you can count on. Thank you, and stay safe out there.